Welcome everybody to another episode of Be Brown Bag. Tonight I have the pleasure of hosting Gabe Maentz at G Maentz. I'm hoping that I pronounced that right. Who's going to do an overview of HashiCorp tools, and we're actually going to get quite a lot of them tonight. So just some quick notes to get out of the way. We have Be Brown Bag. Be Brown Bag is global. We have the main channel in the US, but we also have Latin, EMEA, and Brazil. But we share the hashtag BeBrownBag on Twitter. You can send questions down there. I'll be monitoring. You can if I get any question for Gabe, I'll send it his way. So don't be afraid to reply, even if you're not attending with us live. With that, I would love to give the floor to Gabe. Gabe, go ahead and introduce yourself while I give you control.
Cool. Can you hear me all right?
I can.
All right. Hey, I'm going to go ahead and share my screen, and we should be good. Hopefully that's broadcasting for you.
That looks good.
Okay. So good evening, everyone. We're going to do a little speed dating episode with HashiCorp tools, and we're going to cover a bunch of stuff tonight. So hopefully have some working live demos for you as well. So my name is Gabe Maentz. These are all the ways that you can find me, both in my work and in my pleasure, which goes from left to right. And I am a longtime vExpert, as well as getting pretty ramped up in the HashiCorp stack, which is going to be the topic of things today, as well as a proud founding member of the vBrisket community. So for those who aren't aware of what vBrisket is, it's a fusion of smoked meats, barbecue, craft beer, and technology, something I think most people can probably appreciate. So that's a little bit about myself, but let's talk about HashiCorp. And some folks probably don't know who HashiCorp is because they're probably better known by a lot of the technologies that they create. But they were founded by a couple of pretty smart guys back in 2012, and their mission is to help, provision, secure, connect, and run any infrastructure for any application. So the products that they have are showcased there. There's been a few other vBrownBag episodes on some of these products, specifically on Vagrant, which we'll touch on tonight, as well as a handful of Terraform sessions, which are probably a couple of the more popular ones. So the products themselves are all open source. In fact, everything that I'm going to show you tonight, you can do with the open source versions of the product. They do have some enterprise features for several of the products, but everything tonight will be free and usable by you after the show. This is the number of contributors and committers, and this might be a little dated now, but as you can see, it's gaining lots of attention, and it has a very, very large open source community behind it. And really looking at the mission of this, it's all about kind of automating application delivery. So HashiCorp actually has a TAO that their company works by. And one of the founding pieces of the TAO is to really look at workflows and not technology. So I thought I would maybe lead off with that, because while they have some pretty awesome products, and it's kind of like a suite of products, you don't have to use them all together. They do work well together, but some people just use one or two of them. They're not dependent on one another. And they're really set out to solve different parts of this application delivery workflow. So if you look at a modern day application, you're really going to start kind of here at the top, where you're going to write and test an app, and then you're going to package it in some way, and then you've got to go and deploy it and provision it out to some infrastructure, whether that's an on-prem data center or into a public cloud, or in some cases you might have both of those. And then you've got to figure out a way to connect all your applications together and ultimately do that in a secure way. So what HashiCorp has set out to do, and you'll see what the products, they address each of these particular areas, and we're going to walk through that today. So let's talk about the app we're going to go ahead and deploy, because everybody needs an app, right? And there's lots of them out there. The app we're going to focus on today is part of the Apache project. It's called NiFi or NIFI or NIFI or however you want to pronounce that four-letter word. And it's came out of, it's also an open source product. It came out of the NSA, and its sole purpose in life is really to move data and what they call data flows between systems. So it's very, very popular in kind of the analytics world and how to get information from one system to another. It is a Java application, so don't hold that against it. It does run a massive JVM, and we'll showcase some of that today. But this is the application we're going to write, test, and package, deploy, secure, and deliver here. So a little bit about Apache NiFi. So let's kick it off. So the first piece here in the first product we're going to look at from Hashi is called Vagrant. Now, Vagrant might be pretty familiar to developers and to ops folks as well. It's been featured on vBrownBag a few times. I think Jonas actually did a session on it. I don't know how long ago that was, a little bit ago. But its whole purpose in life is, and where it gained its popularity, is for developers to be able to actually start to create and build things kind of in their production or in their kind of corporate environment without having to, you know, provide admin rights on their computer and things like that. So it works much like the other HashiCorp tools with kind of an infrastructure as code mindset. So let's pivot over real quick into Vagrant. These are some of, it is cross-platform, which makes it very popular. I'm running this on my Mac, but I could run it on a Windows machine or on a VMware, within a VMware environment. So I'm gonna pivot over to Vagrant and do a quick, the way it works is that you actually just create what's called a Vagrant file. So if I look at this Vagrant file, you can see in this case, because NiFi is a big Java hog, I don't have enough local memory on my little MacBook Air here to actually run this on my local computer. But that is actually what a lot of people do. They actually run what they call a box, a Vagrant box, on their local computer, which is completely isolated and allows them to develop and create an application. I'm going to leverage the public cloud because in this case, AWS has lots of memory that I can use. In fact, looking at my Vagrant file, I can go ahead, I'm gonna go ahead and provide some access. I'm gonna provide a key pair so I can SSH into this box. These are some details about where it's actually gonna deploy to. I'm gonna go for an M3 medium today, give it some memory here. And I'm gonna go ahead and place it in this environment. So if I log into my AWS environment, you can see and ignore all of the terminated sessions. I was doing some testing before, but I don't have anything outside of a console server running in this VPC. So let me go ahead and clear my screen. And the way that you can execute that is just simply by issuing what's called a Vagrant up. So what Vagrant up's gonna do is it's gonna read my Vagrant file and it's gonna figure out how to build my environment, and I just have to issue some credentials for it. And here it goes. So it's gonna build an M3 medium. It's pulling AMI from AWS to build this with, and it's issuing my key pair here, and it's gonna go ahead and create this. I think the longest parts of these demos is just gonna be the tear up and tear down of various systems here. It's going to go ahead and get SSH ready for me, and if I go back into AWS and do a quick little refresh, you can see that now I have a EC2 instance here called NiFi development. And that is what Vagrant is spinning up for me.
And I just want to remind everybody, if you have a question, go ahead and put it in the chat. I'll figure out when to put it in.
Cool. Thanks, Ara. So now it's ready for me. And what's nice about Vagrant is I can issue all the commands. I don't have to worry about like all the nuances. I can just issue what's called a Vagrant SSH. And now it will actually deal with, you know, the keys and the IP address for me to connect to it with. And I can just jump right into it. So here's my EC2 instance. And so the first thing I got to do is build and test my NiFi deployment. So like a good developer here, I have a series of steps that I want to use to install NiFi. So I'm just going to do a little copy paste episode here. I'm going to update on my dependencies and all this kind of fun stuff. And it's going to install, this is a Java app, so it's going to install Java. And then it's going to pull down my NiFi binary and install it. And really, this is kind of my own little isolated environment that I can do anything I want in terms of testing. It's very convenient because I can just simply build this stuff quickly and go and perform that test. It's pulling down NiFi right now. And like I said, this is like watching paint dry. So we're 50% done here.
Would you say that the setting up the environment takes longer probably than actually executing? Like how long did setting up the environment can be expected of a beginner, for example?
Well, Vagrant Up, there's tons of Vagrant boxes out there. So people already have like packaged instances. In fact, there's a Vagrant box for NiFi. So I could have just pulled that down and used it. And so to answer your question, Ariel, it's like really fast. I'm kind of building my own here just to kind of walk through the process. And we are going to feature more and more automation as we kind of go through the stack here. So this is probably the most manual part of what we're going to be showcasing tonight. So I'm going to go ahead and load NiFi here. And I'm going to create a service for it. And I have that here as well. And I'm just about done, I promise. But this is what devs do, right? They get things going, make sure all their commands work correctly. And now I have a service that's up and running. You can see it's active, it's running, and it has started Apache NiFi. And now I can tail the log. This thing does take a little bit to spin up, but
Well, it's Java.
It's all Java, baby. It takes a little bit to go. But what you can see here is that I'm in my isolated environment, so no harm, no foul here. So I've got Vagrant up, I'm doing some testing, and I'm going to take the results of that test, and actually once I'm happy with it, I'm going to go and move on really to the next thing, which is Packer, which is my packaging environment. So if I go ahead and look at, just to make sure the app comes up, I have exposed this to the internet so you guys can happily go crash my stuff. This is the power of live demos. So this does take a little bit to spin up. So that's going. And while that's moving forward, it's almost there. I'm going to go ahead and move to the next part of the slide, just in the interest of time. So the next piece that we have is actually the packaging component. So in packaging, there's a product called Packer. And so Packer's purpose in life is to take what you've kind of already built in kind of your test dev environment and to package that and to take code and make an artifact out of it. And what do I mean by an artifact? An artifact could be a VMDK file. An artifact could be an OVA. An artifact could be a Docker container or an Amazon EC2 AMI or a GCP instance or an Azure ARM template. And Packer allows me to kind of take what I've written and tested and deploy these into an image. It works simply with defining a JSON file and running what's called a Packer build and taking infrastructure and taking code and making images. So let's showcase that real quick. Oh, and my NiFi instance did come up before I start building with Packer. Let me do a quick refresh. And wow, the demo gods are with me. My application has been deployed, and this is NiFi. So NiFi allows me to create all these different types of workflows and test flows and connections. So I'm pretty happy with that. I'm going to go ahead and kick off the Packer process now. So just taking a quick look, I'm going to actually show this in a little bit in here. So I have a Packer folder, and I have here's what one of those JSON files looks like. So for Packer, it uses this concept of builders. So I'm going to go ahead and package this for Amazon. And I'm going to go ahead and use a source image here. In this case, I'm going to use an Amazon Linux instance. And I'm going to go ahead and create an AMI, and I'm going to call it this. And I'm going to do a lot of what I just did in Vagrant using a Packer provisioner, but I'm just going to now define it within Packer. And at the end of this, I'm going to have really a couple of artifacts. One is a Vagrant box, which allows me now I can use that for when I'm deploying with NiFi, as well as an Amazon AMI. So if I go back into Packer here and do a Packer validate, and the name of that was, so my JSON looks good, and that validate saves me a lot of time actually, because JSON can get really complicated in terms of you can just miss like a curly brace and you can have a bad day.
Oh yeah.
Speak from experience. So I'm going to go ahead and build this sucker. And here's what it's going to do. Now, I'm only building to one provider or one provisioner, but I could actually, in the same file, have an Amazon, a VMware, and a Azure, for example, artifact that builds. And this does parallel building, so it will allow me to build all of those types of, or a Docker container for that matter. It will allow me to build all those artifacts, all using a consistent image or a consistent way of building it. So that's one of the, and it will actually highlight each of those builds in a different color. Mine is not quite that exciting because I'm just building this on AWS, but I could very easily build the same image on AWS and in my VMware environment, for example. So that, what it's doing, let's just take a look at the AWS console here and just do a quick refresh. Packer goes out and it builds an EC2 instance and it starts to initialize it. And then it's going to run through all of the provisioners and all the code that I asked it to. And then it will actually destroy this image and create an AMI. In fact, if I go to the AMI section of Amazon, you can see that I've built a number of different Packer images here, which I've been doing kind of today a little bit in prep for this demo. Right, but what I see a lot of people do is they have this idea of immutable infrastructure, right? So because it's so easy to take code and to build artifacts out of it, you can put this in kind of your CI/CD pipeline and just simply iterate and build new images very quickly. and you can put a retention policy on those. The nice thing about Packer is because it's just simply code, really nice thing about most of the HashiCorp tools is now I can take this file and put it in source control, and I can version it and build upon it and change it and see if something broke when I updated it and my build didn't work, like what changed. So it's a really powerful set of tools. So you can see this is what Packer's doing. It looks very similar to what we were doing before in terms of the Vagrant, just it's now in an automated fashion, automated setup. Any questions, Ariel, so far?
Not from our audience. Let me check Twitter real quick. Apparently we are against Game 7 of the Stanley Cup, so I guess a lot of Pittsburgh friends will be joining. Well, honestly, Boston and St. Louis.
Boston or St. Louis friends.
Yeah, but this is very interesting. I do get what you're saying about making things that were used to be manual to be more automated.
Yeah, I think the way Jonas said it when he was doing a Vagrant thing before was it says installing VMs manually is just plain out stupid, right? So although I've done quite a bit of that, if I can automate things, I'm all for that. And so Vagrant and Packer were the two of the first products that HashiCorp released. They became wildly popular. And while Terraform, the piece we're going to talk about next, is probably one of the most popular tools, Vagrant and Packer still definitely have their place.
It does feel to me, after seeing a little of Terraform elsewhere, that it built upon these concepts.
Yeah, absolutely.
Now, you and I came from the V community. Most people that are in the V community started from Windows and then went to VMware. That was the first time they saw a Nix console.
Mm-hmm.
I'm going to assume that by now, Windows is not a second-class citizen in this ecosystem.
No, it's not. Vagrant doesn't have the ability to create Windows instances, but Packer certainly can create Windows VMDKs, for example, is probably based on this community is a very common thing. So you could technically take a Windows hardened image, deploy it in your VMware environment via Packer, just simply by writing a little bit of JSON in that code that I was showing you.
Mm-hmm.
And you could then go and deploy that into VMware, AWS, and Google, for example. There are a few gotchas there. You have to make sure you've got a couple of the drivers correctly to work with those particular clouds. But for the most part, like, you can build these things. In Windows is not a second-class citizen. You're correct.
Cool.
With Vagrant, it is a little bit, but Packer and Hashi and all these are Terraform and those tools, it's not.
Yeah, no, because I know a lot of people that are doing stuff with Azure are using these tools. So.
Yeah, absolutely. So here's my Packer image. It's going in. What it's doing right now is it's actually stopping my source instance, and it's going to start to create the AMI. So if I refresh it, you can see that if I go into my dashboard here, you can see my Packer Builder one is tearing down. I hope people can see that. It might be a little bit hard to see, but it is stopping. And what it's going to do next is it's going to go ahead and create a new AMI in here for me, which I can use in my next part of the demo. So there it goes. So there's my AMI, and this is the number. This is the value that I want to be aware of, right? So let's move on to probably one of the more popular HashiCorp tools, and that's in our wheel of app delivery here is the provisioning tool, and it's Terraform. So there's been tons of talk about Terraform lately. So what is Terraform? So it falls into the infrastructure as code provisioning tool kind of bucket. What is very popular about it is the number of providers and people that are using Terraform. If I actually go pivot into Terraform's website and look at all the providers. So what a provider is in Terraform is Terraform's in essence an abstraction layer to make API calls for companies to provision their infrastructure. So there's tons of folks who have created Terraform providers. In fact, if you look at the screen that I'm scrolling on here, there's a good chance that there's lots of stuff that people are either running in their data center or in their clouds that Terraform has a provider for. Their list is quite extensive. I'm pretty excited that VMware has really helped create a number of different providers. They have 4 now: NSXT, vCloud Director, and VRA. Actually have done a fair amount of work with VRA, the VRA provider, as well as a native vSphere one. So the way Terraform works is I can actually go ahead and create infrastructure as code. So in this case, I'm going to go ahead and create a NiFi Terraform file. So Terraform files they end with a .tf extension. They are a JSON-like a language. Is actually HashiCorp's language here that you're looking at. And it uses this concept of providers. So in this case, I'm going to use an AWS provider, and I'm going to go ahead and use that AMI that I just built with Packer, and I'm going to deploy an entire infrastructure for my NiFi application. And I'm going to do that with the ability to kind of name this. I'm going to go ahead and I can change how many of them I'm going to build. So if I go into Terraform, and Terraform has really 3 steps. One is a Terraform init. So that initializes any providers that I've created. So I'm actually using 2 providers. One is AWS and one is Vault. And we'll talk about Vault in a minute. But but if I was using this in VMware, there'd be a vSphere provider, for example, or an Azure RM provider. And then what Terraform is declarative and stateful. So let me dissect that a little bit. So I'm actually going, it knows the state of the environment. So I'm going to do a Terraform plan, which allows me to, what it's going to do is check against my current AWS environment and see if anything that I've asked for or declared in my Terraform code already exists. So it only will add, change, or destroy things based on what's already out there. So in this case, I'm going to add 6 things and nothing to change, nothing to destroy. So this Terraform plan, these are the things that it's actually going to go do. So it's going to build an EC2 instance, which I'm calling Blue 0. It's going to use this AMI, which we built with Packer, not in this last run, but one I built with earlier. There's going to be 3 of those that it's going to build. And it's going to go ahead and add some security groups there. So it's going to add a bunch of like my SSH ports. It's going to open that up. It's going to go ahead and put some additional security groups that NiFi needs. And it's going to open up an SSH port. So after I check the plan, in fact, you can actually export this plan and do a peer review on it or put it into a change control system and actually kind of communicate what's going to happen. So you initialize, you plan, and then when you like what you see, you run a Terraform apply. And that's going to go ahead and actually build my infrastructure based on the code that I specified here. There are some best practices with Terraform. So actually, let me make sure I answer yes to this, because it's like, are you sure? Are you really sure? And I am sure. I'm going to go build this stuff. So while that's building, let me just talk about the code a little bit. So in this case, I am using Vault to actually secure my my AWS credentials. We'll talk about that in a second. And I'm building out some EC2 instances based on this information. I've also split out my variables. So in this case, I can tell you, so the reason it's building 3 servers is because I put the count at 3. And I'm actually going to output some of the results as well. So Terraform also takes care of dependency mapping for us. So because, you know, a VM or an EC2 instance needs a network before it can actually, you know, spin up and communicate, Terraform takes care of that. It knows, hey, you need a VPC, and you need a subnet, and then you need a network environment, and then you need to build your EC2 instances, and then you need to go put some security groups around it. And it graphs all that out for us. So it does all of the dependency mapping for us, which is really, really nice, because otherwise, and that's what makes it declarative. Otherwise, we have to like say, hey, do this step first, and then do this step second, and then do this step third. Terraform takes that and takes all that complexity out of the equation for us. So in this case, I've built 3 NiFi servers. Here are their private IP addresses, and here are their public IP addresses.
That's pretty neat.
Right.
So if I have some experience with Ansible, and I think Ansible is more of that type of thing where you have to follow an order. You have to know what you're doing.
Mm-hmm.
I don't know if you're very familiar with Ansible, but yeah, that would be a definite advantage that I see out of the gate, that it will check my environment and actually, figure out dependencies.
Yeah, so Terraform is stateful, where Ansible's not. So Ansible is just like, okay, here's what you want, here's what I'm going to give you, and it's going to erase anything that's already there. Terraform actually knows what the state of it is, and will, if you run a plan, will say, hey, I'm going to change this on you. Are you okay with that? Ansible and Terraform actually work really well together. Ansible, I would say, is more of a configuration management tool, something like Puppet and Chef and those tools. In fact, I went to HashiCorp last year, and there were quite a bit of folks from Red Hat at the conference who were talking about how like Terraform and Ansible together can really help provision your environment. So Terraform kind of takes care of the base infrastructure builds, and then Ansible kind of starts to put the app layers on it, or the services and things like that inside the infrastructure. Is kind of how I think about it anyway.
Cool.
So let me go ahead and open up one of these NiFi instances and see if it actually built. So that's my dev one. And let me go ahead, and it does take a little while to spin up. So there's a good chance that the application isn't quite ready yet, but we'll keep our eye on that. I'm going to close the dev one out actually. Otherwise I'll have a million different tabs, which I'm used to. But if I go into EC2, you can see now I've got, NiFi 1, 2, and 3 are running, and yeah, they're not ready yet because they're still kind of in this initializing state. But just like that, I provisioned 3 servers, all being able to provide my NiFi application, really just with initialize a plan and then apply. So super powerful. And I'm just demonstrating AWS, but you could do the same thing in Azure. You could do the same thing for your VMware environment as well. So let's talk about Vault a little bit. So Vault is, I'm going to go out of order a little bit. Well, actually, I changed my slides. So I'm going in order. So Vault allows me to actually store, it's a secret management engine. So there's what's a secret? So anything that's a computer or a person is bad at keeping, I would define as a secret, right? So things in the technology world are certificates or passwords or encryption keys or tokens or database credentials, or in this case, AWS credentials. Ideally, we want to keep secrets pretty short-lived, and we want to rotate them as often as we can. Those are some security best practices, and Vault absolutely helps us do that. It is a secrets vault, as well as provides a number of other cool engines, which I'm going to showcase here. So I have a Vault environment running. Here's what Vault looks like. I can go ahead and enable, it has all of these different engines for keeping secrets and dynamically creating secrets. There's one for AD, AWS, Azure, GCP. You can rotate your databases, your MySQL and Postgres databases. It can act as a certificate authority. It can rotate SSH keys if you need it to do that. So what I'm doing using it for is I've actually configured a secret engine called AWS, and I've actually created a role for creating NiFi instances. So in this case, I'm going to showcase this role, which is going to just simply perform these operations. So if you're familiar with AWS, this is just an IAM policy, which allows me in this case to build EC2 instances and to modify permissions if I need to. This is an AWS best practice for kind of hardening your environment. So you only want to grant the level of access that's required to a particular service or a particular user. What is cool about this is I can go based on that, I can generate some credentials. So I can generate an access key and a secret key, which is how I authenticate into AWS, without ever having to store that locally on my computer. And one of the benefits of doing that is that there's a lease that's tied to those credentials. So if something goes severely bad, I can actually go ahead and revoke that password or that secret. And I can specify how long it lives for. In this case, I've got it living for a month, so I should probably tune that back because I'm just creating NiFi instances and that takes less than 30 minutes, as we just saw. So I could probably really dial this thing back. And what I can kind of rest assured that this is going to be secret, it's going to be dynamic in nature and it's going to be short-lived. In fact, if I go into my EC2 environment or my AWS environment and look at the privileges that I've set up, here are the dynamic users that Vault is creating for me on my behalf. And those will expire based on the lease time. So I can go ahead and provision this without ever having to pull these credentials and store them in some text file on my local computer, right? And Terraform, what we've got going on in Terraform is we're actually using what's called the Vault provider. So it has a provider, and I'm just attaching to my Vault server, and I'm generating dynamically my access key and my secret key. It never lives on my machine. So when I run Terraform, it will dynamically create the credentials it needs to, and then based on the lease time, revoke them when it's done.
So I do have...
Vault does a million things. I mean, I'm just showcasing one very simple one for this workflow, but it really, I've seen it used in a number of different capacities.
Cool. I have one question from the audience.
Yeah.
So Graham Mitchell asks us, could you use Vault with Ansible to rotate out encryption keys on routers and switches?
You can. So there's a great talk that I'll showcase to you. If you type in Vault or HashiCorp's SSH key rotation videos. Hopefully I can find it here. So manage SSH with HashiCorp Vault. Check out this link. And it does it for Linux machines. I haven't done it with a router and a switch, but it'd be something to definitely take a look at. So this talk right here is how you can actually rotate SSH keys. I think he does it on Linux boxes, but it'd be interesting to see if you could do it on your network gear as well.
Cool. And I had one question. You were mentioning how this is not saved in your computer, but I couldn't help but notice this particular Vault server, I assume is how you call it, is running on localhost.
It is.
So is it meant to be running like on the network and several people have access to it?
Yeah. There's. I'm doing it out of just simplicity. I'm running it in what they call a dev mode, which just makes it really easy for me to just showcase it. Yeah. But yes, it's totally meant to run across multiple, instances, multiple availability zones, across fault domains, cluster in a clustered configuration. Because let's face it, you don't want your password vault or your vault to go down.
Yeah. Okay.
Good catch. You saw that local host. Okay. I'm telling you, it's live. There's no secrets here.
Yeah.
All right. So I don't know if you saw that, but my my NiFi app came up. So Terraform provisioned it, and here's a data flow that I've built that's running. So yay, that worked. All right. So now that we've kind of tested it, packaged it, deployed it, run some security components around it, let's actually talk about Council for a minute. So Council is a service mesh, or its whole role in life, as we're starting to build things that are, let's use a buzzword here, microservices. These things all work, and have a very specific purpose, but they don't know about their neighbors and their friends. In fact, they're kind of nomadic, right? So like they're lightweight, they're intended to do just a certain function, and they're running in different environments, maybe a container running in a Kubernetes cluster, or maybe in an EKS environment, and they don't necessarily trust the infrastructure that they're running on all the time, right? So, and they don't know about their neighbors. So there needs to be a way for discovery to happen of these services. So if one service needs to talk to another, how does it know about that? And how does it understand what's allowed to, what it's allowed to talk to and what it's not allowed to talk to? So we're going to highlight really kind of a service discovery component here with Council. And it also allows us to do connect, like TLS encryption end to end. So another like, I can only, because we're speed dating here with the HashiCorp tools, I can only go into just a few things, but Council in and of itself could be its own series of vBrown bags sessions, right? So very super powerful, cool tool. So let's take a look at it. I actually ran Council in my environment, and I'm going to go ahead and do what's called a Council members. All right, so in this environment here, I've actually got a number of systems, these NiFi systems, which Council knows about. In fact, if I go into the Council UI, I've actually registered a service called NiFi. So Council knows that these EC2 instances are running NiFi. In fact, not only I know it's running it because I've built in a service check on here to run it. So this is a pretty simple service check. It's just checking if the port is active, but you could run any type of health check here. NiFi has an entire REST API. I could do a lot of different checks. And then what Council knows is that, hey, okay, I've got 3 different instances that are serving up NiFi. What makes that powerful is I can then go ahead and in the way it communicates it is one of the ways it communicates it is I can just simply do a lookup, DNS lookup on this. So nifi.service.council, and I now get 3 IPs back, which looks a lot like a load balancer, right? So here are 3 services that are running NiFi that I can connect to. And if I tear one of these down, or it has a problem, or some things go offline, then NiFi will know that, or Council will know that, and it will not route traffic to it.
This reminds me so much of like the F5 health checks, and this part, like the global balancer. This is pretty amazing.
Yeah, Council is a fantastic tool. Probably people actually are using it in place of load balancers in many places, because they can. We're going to do a blue-green deployment here with our NiFi app, and we're going to leverage Council to do all of the health checks for us. Can you do this with an Amazon ELB like load balancer? Sure, but Council not only provides the service discovery for me, but it also allows me to do some connections and end-to-end communication, even for apps that don't have native TLS built into them. So very, very powerful tool. In fact, I'm going to go ahead and do a blue-green deployment. So what do I mean by that? So if I look at my NiFi environment and just do a quick little check on the version of NiFi. So I'm running 1.8 of NiFi. And I want to update that. That's not the latest version. So I'm going to do that through what's called a blue-green deployment. So the NiFi servers that I've got right now, I'm going to call blue, and I want to move to a green deployment, which is a new version of NiFi. And the way I'm going to do that is to use some of the HashiCorp tools. So I'm going to go back into Terraform. Actually, let me go into Packer first. So you can see that my AMI got built, and this is running the 1.8 version of Packer. But if I wanted to create a new AMI with all of the new 1.9.2 version NiFi pieces, I can use the same JSON file, and I've parameterized this through variables to say, hey, go do all the same stuff, but instead of running it for the 1.8 version, run it for 1.9.2, and here's the download to build that. So once again, you can really reuse a lot of code here and simply through variables go build a entire new AMI that has the latest version of NiFi in here. So while that's running, I actually have some Terraform code here. So you can see these are my blue NiFi ones. These are all the ones running 1.8. And I want to now go deploy my green environment. So I'm going to go ahead and this is a demo cheat, Ariel. I just uncomment this code.
Ah, it shows your
Okay.
experience, Gabe. It shows your
Yeah,
experience.
so really it's the same thing here. I'm just using a different AMI. And the AMI I'm using here is the one that has the new version of NiFi in it. And I'm also just going to simply go ahead and make sure I output all the green environment as well. So let me just save that. And now using Terraform, remember, because it's stateful, I can run a Terraform plan against that environment. Oh, I got an error. A live demo wouldn't be complete without an error.
It wouldn't be
So
brown bag without some kind of error.
yeah, so what is it erroring here? It says, I need a
You probably had some comment somewhere else.
unknown instance. So green public IP. Let me just troubleshoot this real quick. Unknown resource, instance green. Let me just check it here. Green public AWS green. I didn't save. Save, Gabe, save. So there you go. So now it's going to go ahead. It's going to see what's out there in the environment. Remember, the blue environment is still there, but I just added some new things. I want to add 3 new green instances. So the plan's going to come back to me and say, you got some things to change here. In fact, oh, it's only going to add 1 of them. Let me change that real quick because I want to add 3. So back to my variables, and I want to go ahead and add 3 greens. Run my plan again. Always good to run a plan before you run an apply. You don't have to, but I like to kind of know what's about to go down.
Yep, especially when, I can definitely tell now how useful this is when you're managing fleets of servers.
Oh yeah.
So you definitely want to know if you're going to touch 1,000 machines.
So check this out. So I'm going to apply that. It's going to go ahead and I'm going to answer yes to the prompt here. I could give it a parameter where I don't have to answer yes, but I'll answer yes. So it's going to run a plan again, make sure everything's good. It's going to add 3 new servers. So I'm going to say go for it. And once again, back here, I'm going to refresh my IAM. Vault's taking care of building, another creation here, so I don't have to worry about that. And it's going to go ahead and start to build my green servers out. If I go to console now, I'm going to go into my services, and now NiFi has 6 things, or has 6 checks, and now once these register, I'm going to start to see these get added. And right now it only knows about the blue ones, but hopefully if the demo gods are with me, I'll start to see the green ones here shortly. So there I go. Their Terraform is done. It's been building these things. There are the original blue ones that I had. It built 3 new ones, which I'm calling green. If I go into my EC2 instances,
I can definitely tell when you went back to those to the PowerPoint and we had that wheel, how all the products are complementary.
yes, right. Yeah. Some people use them for different things. They don't have to use them all, but they definitely integrate really nicely with each other. So here are my 3 new servers, and they're starting to build. You can see they're kind of in this initializing state. Here's my Packer server, which is still building my AMI. So I got a lot of stuff going on here. Hopefully you're still tracking with me. I can go into console, can start to see if any of those started to register yet. Sure enough, here are my 3 new green ones. So it knows the nodes are up. It just hasn't passed the NiFi health check yet. So it's not going to make those available yet in my environment. If I go to console here and I do a quick DNS lookup on that, I can still see that I've only got the blue ones coming back right now. But hopefully, when those NiFi checks work, I'll be able to route to all 6.
So there is a question that is more towards the licensing part
Yeah,
from Graham, and he said, for Vault clustering, and he found a web page, and it said it needs certain type of storage, but he wasn't sure if Vault clustering is available in the open source or if you have to buy a license. I don't know if
you
you
can
know
do
that.
Vault clustering in the open source. If you want to do take advantage of some of the performance pieces of Vault, there are some components which are part of the enterprise. But you absolutely can build a Vault cluster with the open source product. In fact, let me go ahead and just talk about another V Brown Bag guy that's been on the show before, Brian Crossan.
Yep.
He's got some great content on out here, and he's actually got a designing high availability for HashiCorp Vault in AWS. Graham, this is probably worth your read, but this forwarding of reads and writes, and if you read this article, it'll talk about that a little bit. Some of that is enterprise feature in terms of performance standbys and things like that. But in terms of just availability components and pieces, most of it is covered with the open source product. So Brian does a nice job of kind of explaining that here.
Like be brown bag.
If I go back to console here and refresh, let's see if my service checks are, yeah, so it's not quite there yet, but once it is, we can start to then tear down. So what we're going to do is we're going to keep our green ones up, our blue ones up, and then our green ones, make sure everything is good, route traffic to both for a while. Once we're cool with that, then we're going to start to tear down the originals, the blues, and that's how we're going to perform our upgrade. So rather than going and upgrading in place on the existing systems, we're building fresh. We're routing all traffic to all of them. Once we get the green light that looks good, we're going to then start to decommission, or in this case, destroy the old ones. And this is just kind of a nice rotating application delivery, right? And we're leveraging console here to be able to take care of all of that service discovery and all of that, that load balancing for us. So right now you can see all of them came back. They're all looking good and they're all green. If I go back to my console instance and do a console catalog services, you can see NiFi as a service that I have, and I can now do a simple DNS lookup and all 6 instances come back for me now.
So is that console DNS name working because that's a local machine, and I assume it can be applied to a real website, right?
Yeah, it absolutely can. So Council speaks on it, port 8600 for DNS lookups. So there's a little bit of DNS forwarding stuff you have to take care of. In fact, I am doing a DNS forward for this particular name here to route all service.council to my council server.
Got
But
it.
this, you can change this to any name you want. So arielscoolwebsite.com, and then you just can have council or take care of that for you.
Yep, yep.
But there's a little bit of DNS trickery that you have to do. It's really just DNS forwarding.
Mm-hmm.
So you can classify that as trickery or not. But
No, but if it updates my DNS records for me, that's amazing.
yeah, it also has a full REST API. So I've done some of the CLI stuff here with like the service catalogs and things like that. It also has a REST API. So if you've got an application that doesn't, let's face it, modern day apps speak in a RESTful in an API. It's an API world, right? So you can actually query Council to get API responses back, and then that application can make, how do I communicate to this other app? So quite a few ways to consume all the Council goodness. So let me go here now, and once I'm happy with that, I'm going to go back to Terraform, and I'm going to destroy all my green stuff, or my blue. Let me get this straight. My blue stuff.
Yeah.
So I'm going to go ahead and comment that out, and I'm going to get rid of that, and really just simply commenting out code and saving it. Make sure I save everything. Save all. It's a good thing. And then run a Terraform plan. Okay. So let me just show you one thing before I do that. Let me, I wrote a little script which actually just does a curl. So all I'm doing here is I'm curling against that NiFi service console, and I'm reading the NiFi API and getting the version back. And you can see now I've got 6 instances running, right?
Yep.
So you see this ping pong, right? Sometimes it goes to 1.8, sometimes it goes to 1.9.2,
Mm-hmm.
So once I'm happy here, I know that I've got these 2 different versions going. I'm going to go ahead and destroy the 1.8 stuff. And so Terraform plan says, well, if you apply it, I'm going to take care of all your blue stuff.
Yeah, destroy.
Apply those. How are we doing on time, Ariel? We okay?
We're doing perfectly fine. Listen, I'll stay here 4 hours. 4 hours if you want
uh, you're a glutton for punishment. So it's going to go ahead and destroy my blues, right? And now if I go back to my console little loop here, you can see that there's no more 1.8s coming in.
That's pretty cool.
So I've now successfully migrated my app to the new deployment, and I've done that in a consistent and repeatable way. And now because this is all code, and you can actually build these into CI/CD pipelines and automation components, and I would even venture to say that you get really good at this and get really comfortable with the power of the tools. You can run deployments and run apps in this fashion pretty easily.
And thank God you use. I mean, clearly you're very comfortable with this, and you had the idea of using an app. And this is a very cool demonstration. Um, One question I have is, in this case, you only commented it out, and it seemed to have done it magically. Uh, is that because Terraform, because of the modules, know how to do things, or did you actually have to tell it like the commands in order to do it? Because I guess
No.
I'm looking at this, I'm thinking, wow, this is really powerful. Like anybody could do this.
Yeah, I mean, you have to know the nomenclature a little bit. I guess that's probably where the investment comes in, is understanding like the HashiCorp language a little bit. But you know, I am putting some best practices in here. I like to. You can write all of this code, all this stuff into a single TF file using the HashiCorp language. I actually like to spit out different pieces into different areas, right? And so I like to put my variables into its own TF file and my outputs into its own TF file. And then I've broken out my security groups. The way Terraform does it is if I do a Terraform plan or apply against a directory, it reads all the TF files in that directory. And then the beauty of Terraform is it takes care of all the dependency mapping for me, right? And it treats it all like it's one big file. But for me, a human, it's much more, it's easier to read if I break it out into different pieces. So if I know like, hey, I need to go just change some variables, I don't have to and I don't have to put the rest of my code at risk, because let's face it, if you put it all in one big monolithic TF file and I just go change one variable, but I change the wrong one, I could potentially put my entire environment at risk. So now I'm just simply going and changing exactly what I want to see. So there's some really smart folks and some great people, because this is a relatively popular open source community. If you go into the Terraform module registry, there is lots of people who have already done some of the most common things for Terraform. So if you're looking, hey, how do I deploy a VPC in AWS? Well, boom, there's the module that you can go. Here are the examples. Here are the variables that it's expecting. So you can really get up to speed pretty quickly.
Cool, cool. Yeah, when you are starting to talk about it,
Here are the VMware ones, by the way.
Graham basically said, "Oh, I presume he can automate the removal," but I don't think he or me expected it was just commenting it out. So that was pretty cool.
Yeah, because Terraform's stateful. So what that means is like you just changed it's declarative. You just said, I don't want these things. And I did that through just commenting the code. And then it says, well, you have those three things and you said you don't want them. Therefore, I'm going to issue 3 destroys.
Yeah, pretty awesome.
So now my app is up. If I go back into console, I can see that I'm happy, and I can go into my app. So let me just pull one here. I'll just pull the public IP because that's how I can access it here. My app is up. My flows are there. And I already know this because I made an API call, but some folks like the UI. I'm upgraded.
Pretty cool.
And that's what I got for you.
No, I mean honestly, we only had a few people here on live with us, but especially for people that came from the traditional Windows and vSphere admin, this has been very enlightening, and I really appreciate it.
Well, thanks. I think we should maybe engage some other folks if we wanted to. I just like I call this speed dating with HashiCorp, right? But I think for those who are inclined, and there's already some good content out on the vBrownBag site around Terraform and Vagrant and things. But I think it would make sense to maybe even call the community out to see maybe if we can do some deep dives into some of the other products as well. But hopefully this gave people a taste maybe of where we could maybe go deeper. So
I'm very interested in console. Like I might schedule you again just to do a deep dive on console.
yeah, Council's very cool. We didn't even get into the Council Connect stuff and the micro connectivity and secure connectivity. Consul's kind of a Swiss Army knife. You can do many, many things with it. But it all comes down to the use case, right? So what are you trying to do, and how is it making your day-to-day operational task easier?
So we have a question from Jeremy A. And he says, "Could we circle back to the role that Vagrant plays? I kind of
Yeah,
got lost. I kind of got lost in the contribution once we started with Packer and everything else."
yeah. So let's rewind here real quick. So Vagrant, once again, is just a really, really easy way to get an environment like just a VM up or an instance up where I can just start to, have my repeatable environment. Maybe I've got my environment variable set in there. Maybe I've got a bunch of images and Java versions and all that stuff, and I don't want to have to go like reinstall all that. I just want I want to start from like a base, kind of think of it as like a VM template, right? Like I know what's in there and I want to go, code some stuff and look at stuff, but I got to make sure that I have a consistent environment to start from. Vagrant makes that really easy, and not only I don't need like a separate VM or a EC2 instance, but I can do it right here on my VM Fusion or my VirtualBox right out locally. So here's my Vagrant here. I'm going to exit out, and what Vagrant is really nice for is I can do a Vagrant. I don't have to get stuck in all the minutia of like what my SSH keys are and how do I deploy the security group and some of the stuff that we touched upon as we kind of built through this. I can just run like a Vagrant status on this environment, for example, and I can see that, hey, okay, I'm running and I'm running in AWS. And if I want to attach to it, I just do a Vagrant SSH and I'm in. And I can start working from there. And then if I really botch things up and I really just want to start from that clean slate again, I can exit out of here. I can halt the environment, which really just stops the instance. So if this is running AWS and I don't need it running the whole time, I just run a Vagrant halt, and that will actually, if I refresh my screen here, you can see the development one is stopping. It's in the stopping state, so it's bringing it down. And then if you really want to make your operators happy, you just do a Vagrant destroy, because it feels so good to destroy things. And that just means, hey, boom, I want to just tear that environment down. I did my testing, or I downloaded the wrong stuff, and now I've got all these dependency issues and things like that. And if I needed to get back up and running, I can just simply look at my Vagrant file, and it will build everything clean just based on the specs that I have here. There's tons of Vagrant boxes already built if you want to pull them down. They're kind of like, they're not containers, but they have that same kind of premise as a Docker container, right? There's probably a container out there that somebody has built. This kind of predates containers in some ways. So all these different Vagrant boxes are out there. So how do you, there's a public catalog of all these different boxes. So if you need to pull down an Ubuntu instance or a HashiCorp, you can go ahead and look at all these different ones. And this is just like an OVA file. Think of it like that, right? It's just you pull it down, you can run it locally. It's got all this stuff that's already pre-canned for you, and you can spin it up and spin it down. And then you can share it with people. So once you get you're a developer and you've got your kind of gold image, if you will, and you want other developers to code off of that as your base, you can share Vagrant boxes. Hope that answers the question.
Cool. And I'll send the link out to Twitter as well. But yeah, it does feel like a lot of the concepts that we take for granted today. I wonder if Vagrant was like the first thing that came out. It does feel like Docker in a sense.
Yeah. I think Docker could, it'd be interesting. I think people are doing more in containers now, but Vagrant had its purpose. So it's funny, I work in corporate environment quite a bit, and you get handed this laptop, And if you're a developer, it can be really frustrating because like the IT team has locked the thing down. You don't have admin rights. You can't pull things down. And all of this makes sense, right? There's security, concerns and things like that. But to a developer who's just trying to code something and get something out the door, sometimes you need to pull things down and use it and test it. And Vagrant just gives you a nice little isolated environment to do that without screwing up your corporate computer, right? It's nice.
Yeah, and it's definitely like, Docker is great for containers, but this feels like you can do whatever you want with it.
Yeah, I've got a full, Ubuntu or CentOS or whatever flavor at my kind of disposal without having to, dual boot into a different one or anything like that. So it definitely takes advantage of kind of the virtualization abstraction for sure.
Okay, so I don't see any other questions. I'd just like to end with two things. First, what would you say is a good way for people to start? Like, what did you find was most useful? Just going through the documentation on the HashiCorp website, or seeing videos, or looking at code?
Yeah. So I learn by doing. That's my way. And so it helps me if I have like a use case to go do this with, right? So the one I started with was Terraform because first of all there's a lot of kind of I don't say hype. I think it's well beyond the hype cycle. I think it's really useful, right? And there's tons of providers out there, so there's a good chance that it could be used in your environment. I mean, if it speaks an API, then Terraform is a great place to start. And the community is very rich, and there's tons of stuff. If you're going to go down the Terraform track, and this is how I started, there's a great, go Terraform's website. There's this great learn option right here. And in learn, like it walks you through, like this is a 5-minute task on how to install it. Here's a 5-minute task on how to plan it, build it, destroy it. And this just is really, really fantastic. Hashi has done a great job of putting together their learn environment. And if you're a developer, like here are a couple topics which might be pertinent to you, or if you're an ops guy like me, like here are a couple of things that might be pertinent to you. So I would direct people to the learn page, and each of these, so you want to learn about Council, go to Council and go into, they have a guides area and they're working on learn for this, so they're starting to roll that out. But I would go into the guides and into the learn piece for each of the products. Vault has the same thing. So if you go to Vault and there's a learn guide there. How do you do Vault? So Graham was asking about how to do how to create your first secret, and how to enable your first engine. And there's a whole thing on here about how to do high availability and build your cluster out. So these are all great resources.
Awesome. And the second thing was that I just want to thank you. I know you're a big community guy. This is the kind of thing that one needs to get started a lot of times. So I really
Yeah.
appreciate it, and thank you so much for coming on and doing this for us. It just, you can tell that you put some love into it, so I appreciate it.
Yeah, no worries. Thanks for the invitation. My first time presenting on vBrownBag. I've long
I,
wanted to do it. It's funny. Sometimes it's just an invitation. So thank you.
have you ever done a tech talk?
Have I ever done a vBrownBag Tech Talk? I don't know if I ever have. I was going to a VMware World last year, but I think the agenda was full by the time I found out that I was going. But yeah, this is good stuff.
All right.
Thanks for the invitation, man.
I really appreciate you coming, and I do encourage you and everybody else out there to submit. We still have, I think it's until June 20, uh, openings there. So please go ahead and do that, Gabe, and do that, everybody else. And any shout outs you want to do before we close out the recording?
Oh boy. Any shout outs? I don't know. Maybe we'll have a little bit of vBrisket out at VMworld this year, and
Ooh,
see some folks there. So
ooh. So I am involved with VM Underground as well as Alistair. We
sweet.
actually started with the opening X panels, the topics and all those things. So yeah, reach out. That's how I met you. I met you in VM
Yeah,
World a
that's right.
long time ago with when we Brisket did the opening acts catering.
Yeah, right on.
All right.
Yeah, good stuff.
Okay,
Thanks,
I'll close
Ariel.
this down.
Thanks,
Thank you
everyone.
so much, Gabe. Thank you everyone for attending.